Students, as we have seen now that how current is producing magnetic effects and how we have generated current by using the magnetic field. Okay, that is vice versa. So let us see how the thing that is got produced, that is induced current, is now get to our homes. So that is what this topic is including, that is domestic electric circuit. Okay, so what is in it? Just we are seeing here that first how the electricity get generated and where it is going to be generated. So it is going to be generated at power stations. We call it as power stations. We are going to see the pictures also right now. Okay, so this is the basic thing, basic place where we generate in a bulk amount. The current will be generated here in a very bulk amount. Okay, now then the supply electricity to the houses, and this could be through the electric poles that you can see. Most of the countries are having these kinds of electric poles. Through that wires are going to be around and that is going to supply the current. Even we can see here in India, in different colonies, there are certain electric poles. But that electric poles are having a lot amount of voltage. Okay, and that is going to be reduced when it is coming to our houses. So what is voltage is coming to our houses? The voltage supply that is coming to our houses is 220 volt. Okay, that is V. I have told you what is the SI unit of voltage? Volt. Okay, and now what is the part of current? How much current that we can draw in a residential area? Maximum is 15 ampere. Okay, and we are not supposingly like this is not a less amount. Even a big things in our house can work up to 5 ampere of the current. So that is mainly is used when you are purposingly applying a very big machines at home. Then only you will need that much of current. Otherwise, all the basic necessity appliances that is present in our home is working on 5 ampere of current only. Okay, so this was the domestic electric circuit, that how it is looking. It is looks like this. So as I have told you, we will show you the power plant. So this is a sort of power plant, that is we can say thermal power plant is it the example. So there are various power plants like nuclear power plant, hydro power plant and atomic power plant and thermal power plant, in which we are just generating energy by using some natural resources, and that is too with the help of water, because ultimately what we need a force. You have seen that in generator case we are having a magnetic field, we can generate that. But if we need force, okay, for that much thing we need some natural big energy that is producing a large amount of force. Okay, so for that we need natural resources. So these are located, these power plants are always get located nearby to such an area where we can get in a bulk amount of natural resources. So when we generate a large amount of energy with the help of generators that we have seen in previous slides, so then this get transformed. Okay, now the thing that is going to be transformed for the transmission. So first of all, it is going to put here transformer for the step up voltage. What is step up? Now here the voltage that is produced by the power plant is of very high amount. Okay, very high amount of voltage is got produced there. Now keeping it at that level, and when we are going to supply it through wires, so it is going to be reduced somehow, because electrons here, all the points, all single points that is present on this wire is getting dropped down of each voltage. So we can say that this is known as voltage drop. So जितना बल्क में आपने यहाँ इतना सारा वोल्टेज बनाया था, तो वायर्स के थ्रू वो सारा का सारा ड्रॉप होता चला जाएगा, एंड व्हेन इट कम्स टू आवर हाउसेस इट गेट्स वेरी लेस. Okay, so but we need that thing and it could be in our control. So that for that thing we need transformers. Okay, so transformers are just a thing that can enhance the production. Even if you are producing any 500 volt of voltage, like let's suppose potential energy is of 500 volt and you want to enhance it, you can enhance it also with the help of transformer. And if you get transformed it like 1000 volt, and when again you want to reduce it to the 220 volt, let's suppose. So you can do that also with the help of transformers only. So there are two types of transformers basically. One is step up transformer and one is step down transformers. Okay, here is the step down transformer. So what we need earlier, we need a step up transformer so that we can enhance the produced voltage. जो हमने potential energy यहाँ पे बनाया इतना सारा, that is again going to be step up and it is going to be increased just because we want to transmit it from one place to another. And when we are doing it like transmitting it through the lines, so electricity goes long distance, so there will be potential drop. So later on when it is going to be transferred and now it is received at some station, these are known as substations. Now these substations are having again the transformers, but that transformer is receiving again a huge amount of voltage, because here the voltage that we have stepped up, that was too high, and the long distance that has been traveled, it has used a little bit of amount of voltage drop. But again, before supplying it to our house, it is again going to be stepped down little bit so that it is not harming any of the appliances that is present in our home. So that is done here at substations, and now from substations through the electric poles, each and every house of our colonies are getting the electricity. Students, as you know that we have received the electricity at our home now. So what is happening afterwards? So electric wire reaches our home through the main supply. There is a single wire that is hanging on the wall through pole to pole, and from there we are getting one of the connection for our home. That we can say that is a main supply, and that is again going to be divided into two parts. One is main supply that is carrying it. This wire is known as live wire. So it is of red color, we can denote it as the red color. And one which is not carrying anything, that is known as neutral wire, that is of black color. So like this is the main wire that is going from one pole to another pole like this. Okay, so from here we can just draw a current for our household, that is known as main supply. That ki main supply yahan se aa rahi hai, and this line is known as the live wire. Okay, this is live wire. Why? Because it is carrying voltage. It is putting itself in a voltage, that is 220 volt. Now this is coming to our house, that is of red color. But one more line, one more thing that is coming to our house is the neutral wire that is having 0 volt, no volt at all. What we are going to make, actually when we are, let's suppose this is some appliance, okay, let's suppose you can take it as a cooler or a fridge or something, anything that is using in your house. So here we are having one wire that is connected to the live wire, and here we are having the another wire that is connected to the neutral wire. Why we are doing this? Because you know when we were learning, we were studying the electricity chapter, then I have told you that according to the live and according to the neutral's voltage difference, this appliance is going to be work, because we are applying here 220 volt. So the difference between the potential energy is going to make the electrons to move from one position to another, and moving the electrons with a great force. That is the only thing we need. That is only thing that is going to produce the current. The force with which it is going to be dragged or drawn, electrons are going to be moved. That only generating the current. So current is the rate of the amount of charged particle that is moving from one particular point in a time. Yeah, right? So let's suppose for this particular point, if we are talking, so how many charges are moving from here for just a time being, like for just a second, how many charges are going? So it depends upon the voltage, the difference between. Even I have given you the idea of this one. Okay, like suppose we are having two beakers and it is full of water, and once we have attached it with like this is blank. So let's suppose this is the potential full the beaker, and this is the neutral wire, like none of the voltage is here. So when we are attaching it from here, so it is just having the pressure of the water till this to this place. So it is the water stream that is coming into the vacant vessel will be of very less pressure. But if we are connecting it to from here to here, so now it is having a lot of pressure from here to here. So that is going to give you the idea that how the pressure works, and that pressure in terms of electricity is known to be as the potential. Okay, so here the live wire is having a high potential, that is 220 volt, and neutral wire is not having any sort of potential energy, just to keep the potential difference equal. Okay, like there must be a potential difference, so we are using it like this only. So in our home we are getting these two main wires, and that is known as main supply, so that we can get 220 volt. We can use 220 volt properly. Now, how does it look? So, our domestic circuit looks like this. So, you know, here we are having a live wire and a neutral wire that is of black color. Red color is for the live wire and green color is for earthing. What is earthing now? Okay, earthing wire is nothing but is just to keep our appliances safe. You might have heard that कि पापा बोलते हैं earthing करवा देना चाहिए हमें बड़े appliances का. Why? Because it can draw. Big appliances maybe lose some wires and the wires got attached to the surface of the appliances. तो यहाँ पे सब जगह इस appliances के चारों तरफ electrons जमा हो जाएंगे, और जैसे ही आप इसको टच करोगे तो ये इलेक्ट्रॉन्स आपके अंदर आ जाएंगे एंड गोइंग डाउन टू द ग्राउंड, बिकॉज एवरी इलेक्ट्रॉन टेंड्स टू गो टुवर्ड्स द ग्राउंड बिकॉज इट वांट टू गो फ्रॉम हाई पोटेंशियल टू लो पोटेंशियल, एंड ग्राउंड इज tend to be as the 0 volt, always 0. So always electrons wants to move towards the ground because there is a potential difference between the appliance and the ground, and they want to go to the lowest potential. Okay, that is why what we can do, we can just protect ourselves by keeping this appliances attached to one of the wire that is attaching to its body, and we are just putting it into ground like this, so that if by chance any electrons that is collected over the surface of the appliances get through this wire and get into the ground easily. So this is known as earthing. Okay, so here the domestic electric circuit of our houses looks alike, in which live wire and neutral wire are going like this, and here we are having electricity board fuse, that is the main fuse we can say. So that fuse is what? It is used to keep our house again safe. You know that we are drawing this 220 voltage, and that is again similarly going to give us almost 15 ampere of current. Am I right? Okay. Now by chance, in case this step down process is not going to be proper at substation and it is going to give us the high voltage of current for a second only. Okay, so now what is happening? If there is no fuse wire here, then all the current can drawn here from the live wire and can get affect our appliances, because they are only made to work on a minimum amount of current. Even for some appliances 15 ampere of current is very big. Okay, so accordingly they draw the current. Now, if in case a lot of amount of current is drawing here, then what is happening? Our appliances will get damaged again. That is true. Now, to protect them, what we can do, we just put a fuse wire here. And that is what we are having, a fuse wire that is going to melt itself at the time of the high amount of current. That is made up of a wire. Okay, so here a fuse wire, what is going to do, if a lot of current is drawing here, it is going to melt itself, and now this breaks the circuit. So circuit is going to break here. That is again very helpful for us, because now no current will go again to the forward direction. So this is the main fuse for the main electric supply. Now again coming to the forward, that is electricity meter, that is helping us to calculate our energy, electrical energy. Okay, so meter is using electrical energy, and that is again in what term? That we have seen here, I square RT, that we have used, that we have learned in the chapter earlier. So that is the electrical energy, electrical consumption, how much energy, electrical energy that we are using particularly. Now this meter again is going to distribute the energy. After this, whatever energy we are using at home is going to be calculated by this meter, and that is now attached with this distribution box that is containing main switches, fuse for each circuit, and fuse also, like it is a main supply fuse, so it must be protecting for the whole meter and all the things that is coming inside the house. But even if we can put a fuse for a particular appliances, that we can do also. So here the main switch and the fuse for each and every circuit is provided here. Now we can just put the wire with these sockets and connect it to the different rooms, and here for different rooms also we are having different sockets, and there we can use electricity well. So this is what our domestic electric circuit looks like. I hope you understand it well, and remember the things, and this diagram is very important for in point of view your exams.